I'm CK. Today we've got another pair of kits from Mitch Electronics. It's his 555 Astable circuit, an Astable free-running oscillator, very precise and can be very precise. And we've got a surface mount version and a through-hole version. So we'll take a look at the parts in both of them, and we'll build both of them. I will put chapter markers, of course, showing you where the SMD version is and where the through-hole version is. So if you don't want to look at both, you can look at the one that you're most interested in. And I hope you enjoy the video. Here are the two bags. This Astable is the through-hole version. This one is the SMD surface mount version. Here's the URL, which I am going to assume will take us to a great Mitch Electronics webpage that will probably have a simulator, have a good schematic, and lots of good information. Now, of course, not of course, I'm sorry. 555 timers, if you're not familiar with them yet, are really important. You'll find them in so many things, being used as timers, being used as oscillators, being used as on-off gates. You really need to learn how a 555 works and how you may be able to work it or use it in your circuits in the future, or understand what might be going wrong in a circuit if the 555 has failed or something like that, which is rare, of course, but it can happen. I'm not going to try and describe how it works in this video. There are much better videos devoted completely to describing how a 555 works, and I will not try and offer something that's not as good as theirs. So just look it up on YouTube or whatever search vehicle you want, and you'll find plenty of examples. So let's look at the through-hole stuff first. We've got everything out of the bag. There's not much in the bag, which is why we're doing both kits in the same video. Mitch Electronics 2022, a LED, variable resistor, another resistor, another resistor, a capacitor, another capacitor, and here's where the 555 will go. Here's voltage in, ground, and an out pulse. I don't know what that's coming from. What is it coming from? Let me do what I usually do. I take a little piece of wire or solder, and I stick it through the solder hole, and I find my pointy thing. Where's my pointy thing? Here it is. And I trace to see where this is coming from, and this is coming from pin 3 of the 555 chip, which I believe this is, and that's also going to the resistor, which is going to the LED, so that's the output. Then we've got a 9-volt battery snap cap, a variable resistor, which will allow us to vary the rate of the square wave. And we've got a little resistor. Are they both the same? Yeah, they are. And we've got a 10 microfarad cap. And here's the 555. These are really inexpensive too. They're just made like popcorn almost. 104 100 nanofarad decoupling cap, but this and the capacitor and one of the resistors really sets the rate of the oscillations. This resistor is just current limiting for the diode. So that is the through-hole. Let's look at the SMD, and you'll see one thing immediately that's different in at least Mitch Electronics kits of this, for good reasons. Everything's out of that bag also, and a snap cap, and clearly a much smaller footprint circuit board. And we've got our electrolytic cap, We've got the 555 chip in there. Not too bad. It's not, the spacing on the legs is not the minimum, so it's not too bad to hand solder. Then we've got strips of 100 ohm resistors, 1K resistors, and 100 nanofarad IC capacitors, the decoupling cap. So one of these little guys is equivalent to this. Now you'll notice that while we only need one 100 nanofarad cap on this board, should be only need one. Oh, I forgot something. Hold on a sec. I need to remember to say something. He's given us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because if this is your first or second or 100th time of doing hand surface mount, or even solder paste and oven surface mount, the chance of dropping one of these is really high. And in my case, if I drop this on the stained concrete in my workshop floor, in my workshop, I will never ever find it. So he gives you 10 of each. So that's really nice. And here we have the variable resistor. This is so tiny. These are a little bit of a pain to solder on, by the way. So when we do that, I'll hopefully be able to give you some tips on it. But that's a tiny little, again, through hole, surface mount. Obviously, this can't take the same amount of power or dissipate the same amount of heat that other one can, but it all works. And then here are the red LEDs. So that's it. That's all the bits and pieces. Leave a comment on which one you want me to assemble first. Just kidding. I think I will do the surface mount one first. So if you're not interested in the surface mount, go ahead to the description or the timeline of the video and skip ahead to the through-hole version. Now I'll get the soldering iron heated up and we'll get this thing put together. These things. And I already forgot which one I said I was going to do first, so may as well do the surface mount one first, which is what I think I said, but I'm not certain. So let me bring up the QR code here and see if this resolves. I had a problem with, there we are. Here we have the good web page. Here's the schematic showing the power coming in, and then the variable resistor, the other resistor, and the capacitor, which set the timing. And you can see the pinouts from the 555, including, as we saw, the out, which goes to well, it doesn't apparently have the out on the surface mount board. Okay, it has the out on the through-hole board, which also goes to pin 3. And it tells you what the trainer kit does and how it works. Component list. PCB picture is not there, apparently. And it doesn't have the simulator. I noticed in the past that sometimes he will do that only on the one page. So we'll look at the through-hole version. Same schematic, and yeah, on the through-hole version, let me back this up I don't want to back that up right now. On the through-hole version, he's got the simulator running through there. So you can get a lot of information from this. It is a very good, again, I am very happy with Mitch Electronics and the information they give you. Let me get back to this page because I will want the component positioning info. And I've got it fixed focus on here. So what we're going to do is we've got the component list down here so we know where things go, where 100 nano goes, the electrolytic, the resistors, 2 resistors, and the pot. This, again, this little potentiometer, that's a 100K potentiometer. Just amazing what we can do in such small packages. But what I'm going to do first is I'm going to do the 555 timer. I'm going to get my hand soldering solder, which is my 0.025 inch diameter solder. And I've got my chip quick flux, which I'll be using for the chip and maybe for the variable resistor, but I'm not sure right now. But I'm going to, as I say, I'm going to do the chip first. And what I'm going to be doing is I'm going to tin one solder pad first before I do anything else. Get the little chip baby out. There's that. And see, he doesn't mark this well as to which place the pins are, but I can see it because we're looking at R1 right here, and R1 goes between, it's on chip 7. 1, 2, 3, 4, 5, 6, 7 right there, and 8. So this is 8, so this would be 1. So that's where the dot is. Now let me get my little tweezers. Double check I'm still in the camera frame, and I am, and I'll try to keep my head out of the shot, but I will be looking right down for right now to make sure I've got the legs lined up with the pads, and they are. Now I'll get my head out of the way and reheat that solder I just did. And that locks it down so it's not going anywhere. Now I can do my other little things. Maybe I should come in a little closer. I'm going to zoom in a little. That's as much as I can do with that lens, and I'm not going to get up and switch lenses. So next I'm going to take some of my chip quick flux, not a lot, just a little. This 2-ounce tub is going to last a long time. That's actually too much. So I'm putting it on these pins to keep the solder from going where we don't want it to go. Now we'll put my soldering iron tip between these 2 pins and kind of draw these 2 legs and kind of draw the solder across, and you may be able to see that the pooled flux is keeping the solder from running between the tinned leads. So the solder only goes where it is supposed to go. I don't use flux on resistors, capacitors, and LEDs. I only generally use it on integrated circuits with 3 or more pins, because I find the other ones we can control the, so oops, got extra solder on my tip that went on another solder pad. Fortunately, it's not a problem right now. Oops, and that did bleed through, but I got it off. We're just moving my soldering iron around a little bit. And there, that is that chip in place. I'm going to pick it up and look at it. Yeah, everything looks good. And we do have a dab of solder on one of the R1 pads, but I don't mind that. So I'm going to put my chip quick away. And what I'm going to do next, only because the last time I did this, I struggled a little bit with this component. So I'm going to do the variable resistor next. Again, I'm not going in any particular order, except the order of what my experience with this component has showed me. So this is very, very tiny, and the contacts are very, oops, I almost sprung that onto the floor. I had to hold that gently. Okay, that seems to have gone on well. I do have to push it up a little bit further. I think that worked. Yeah, I think I can make that work. And I am going to use a little bit of chip quick here. I think I still have some on the tip of my pointy thing. I'm going to put some chip quick between these two contacts on the variable resistor, and now I'll do the two legs that we have left here. I think that's good. Did I get the other one at the same time? I think that's good. I'm going to pick it up and take it out of the shot so I can take a look. Yeah, that looks good. Again, sometimes you just don't know, and you have to press on, and when you get it all put together, you'll say yes or no, I got it right. Next, I'm going to do the electrolytic capacitor for this kit. Pull that out of its little bag, and again, autofocus is off, so it's a little blurry when I put things close up to the camera. Now the plus side has got a little indication, a clipped edge and a little plus sign, and that means the side that has the black crescent is the negative side. So we'll do very similar to what we did for the IC. I'll lay a dollop of solder down there, turn it this way so I can manipulate it with my tweezers better. There we go, that contact is completely covered, which is what we want. Now we'll get this contact on this side. Here we go. That's all dandy. Now we've got the, quote, easy bits. We've got the diodes and the resistors. And I'm going to put the diode on first. Just one of them. And I'm going to take a look at, I'm going to get a piece of paper towel because I've got chip quick on my tweezers. And that makes them sticky and pulls components towards you or away from you. So I just wipe that off. And I'll get one of these diodes out. Little bitty diode. And on the back shows you the triangle. And if we're not sure, and I'm not quite sure which way, the mark, again, the board software being used here does not really tell me clearly which way, but we can see that there's a trace from R3 going to this side of diode 1, and if we look on the schematic, there's R3, and that's on the anode side of the diode. The non-green side, again, there's a little green marking on that diode on one side, that's the cathode side, and you can see the same thing, little triangle underneath that shows you where the anode is and where the cathode is. So I'm going to put a dollop of solder on the cathode side. Pick up my diode, slide it on in, let it cool, and there we go. Pretty quick and easy. Now we're on a roll. While I'm here, we already got some solder on one of those connections, so I'm going to do the other ones. I'll put a little dollop on R3, and a little dollop on R2, and a little dollop on C2. So we're all ready for all the rest of what we're doing. And where did the parts list go? There it is. And we'll take the 100 nanofarad, which is C2, and I'm going to do that next because that's the one that things will get in the way of if I'm not careful. Let me get this out of its little piece of paper. Again, you may complain, and I certainly do, about getting these components out of these paper packaging reels, but always remember, these paper packaging reels are for machines to build this, not for humans to build it. So the little packaging is saying, hey, shut up, I'm doing my job. I'm designed for a machine, not designed for your big clumsy fingers, you silly person. Put me on a spool feeding a layout machine and I'll show you what I can do. Yeah, it's saying all that. This electrolytic, I keep banging my tweezers into the electrolytic, causing it to wander around a little bit. Gosh darn it. There we go. It stood up on end and I had to convince it to go back flat. That's C2. Now let's get R3. Let's see, what do we have? We need two 1K resistors for R1 and R3. And as you'll notice, I'm already ahead of the game. I've got 9 100 nano caps left because I didn't drop anything on the floor. That's how you build up your stores, isn't it? Extra parts from kits comes in very handy. Just drop that in here. That's good. And we want R3 also, right? That was R3. We want R1 also. Good. I'm going to do the other ends of these just so I don't forget. Okay. I dropped my hat. Fortunately, I have another one on the desk. Now we will do R2, which is the 100 ohm. Take one of those out, and again, we got 8 1K resistors as spares now, even though, of course, I have got books of SMD resistors. But it's always good to get take advantage of stuff that's dropped in your lap. I'm going to flip this resistor over. You don't have to. It doesn't, electrically doesn't matter. But I like to see the value side when I can. Now we'll push that together. Let it cool, except I moved it while it was cooling. That's good. To the other end. Okay, so that is all the SMD. That's all the surface mount stuff. As you saw, it went together pretty well. Obviously, I mean, I'm not going to say it's super easy. I've done this a lot. But once you get the hang of it, resistors and capacitors and LEDs, are, even the chip we put in, they're pretty straightforward to hand surface mount solder. And I'm an old guy with not 100% eyesight and shaky hands, and if I can do it, y'all can do it. I'll get the 2 battery leads in. Come on, little red battery leads, stay in there. Am I going to have to get locking tweezers out, or are you going to cooperate? Nope, I'm going to need to get locking tweezers out because you're not cooperating. There, what do you think about that? Right, so that is that for the surface mount version of the Astable 555 oscillator. Now let me go get some a rechargeable 9-volt battery, and we will turn this thing on. I'll turn this overhead light off for a little bit, even though it doesn't make much difference nowadays. Cameras respond too well. I'm going to take this off autofocus because I'll probably move it around. Let's see, there we go. You can see it's blinking. Blinking very well. Now the next thing I'm going to do is adjust the blink rate. I got to get my I don't know if these, see, that's too thick. I got to get my really fine tweezers. Hold on a sec. I mean, not tweezers, screwdriver. And of course I couldn't find it. So what I'm going to do instead, I'm going to use these locking tweezers. Turn the rheostat if I can. There. You can see it's slowing down. The period is much slower. Now we'll speed it back up. See how many turns I can get. That's going pretty fast now, isn't it? Here, blip, 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 blip. So that's the way SMD Astable 555 timer oscillator works, and you can see it's a really simple circuit. And just imagine that's a square wave pulse. I should probably probe that. I'll do it on the through-hole one because it's going to be harder for me to get oscilloscope probes on this. But that's the way the surface mount version goes together. Went together really pretty quickly, works just fine. You can imagine the use you can put that to. And If you only wanted to see the SMD version, I hope you enjoyed the video. If you want to see the surface mount version, just wait another cross dissolve and we'll start putting that one together. Welcome back if you watched the through-hole version of this. I mean the SMD version of this, and welcome to it if you skip the SMD and just want to see the through-hole. So let's go. We have the web page up. Again, Mitch Electronics does a very good job with this. You could just go to their website and look at these and breadboard your own stuff. You don't have to buy the kits. Here's the schematic. And here's a simulator showing how it actually all works. Showing the output. Very nice, so you can play with it before you even construct it. Tells you how a 555 is, the pinouts, and how does an astable circuit producing a regular square wave work. Block diagram, component list, and the circuit board, and some usage ideas. Very worthwhile. Now, one thing I did notice, there is no R3 on this board. So we have, if you look on the schematic, we've got R1 and R2 and R3. R3 is the 1K current limiter for the LED, and these are to set the timing for the 555, and we only have R1 and R2, but we actually don't have the 100R. Oops, golly, don't spin around like that. I should have locked it. We don't have R2. We don't have a 100 ohm resistor. All we've got are the two 1K resistors that go in R1 and R3, and no 100 ohm resistor. And as you can see, we don't have an R3 here, we just have R1 and R2. So I don't know whether the people at Mitch mispacked this one and just gave us two 100Ks for R1 and R2, or we want to just use, I'm now struggling with this. I want to figure out what we're doing here. I want to make sure this R2 is actually the R2 that we have. Okay, see, this is actually what is labeled R2 on the diagram, on the schematic, as 100R right here, which is supposedly this on the circuit board right here is not, because this R2 actually goes right to, if you follow the traces on the back, goes right to the LED. So it's, and let me make sure it's coming from the right pin. It should be coming from pin 3. So let me go put a piece of wire through pin 3, see where that's going. That's going, yeah, to R2. So this schematic is mislabeled for this board. This is actually R3, because this is the current limiter going from the output of pin 3. Oh, there goes my stupid water heater. I'm going to have to take a little break. Alright, so that's out of the way. Now, of course, the component list has the right values listed for everything, so just don't be confused by the schematic not matching what you're seeing on the through-hole version. Just go to the component list and you'll be fine. So I just put these two resistors on, quick and easy. I'm not even going to solder them right yet because I'm not going to slow down for two resistors. And we'll put the socket on. Actually, yeah, I guess I'll put the socket on. It makes it easier for me to scrounge the chip back out after I'm done with this. As you can see, there's a notch on this socket that matches the notch printed on the circuit board. Now I will solder these because nothing's holding this socket in place. So just let it sit like so, and I don't have to worry about it being flat to the board, because as it sits like that, it is flat to the board. So I'll just do all the connections we have set up here. And I'm not going to trim those resistor leads right this second either. So I'm going to put the little 104 decoupling cap in, 100 nanofarad. Conditions the power going to the integrated circuit. Gives it a little power reserve and does a little bit of power filtering, for lack of a better term. You can find great resources on what decoupling caps do in circuits many places. And there's that so far. Now we'll put the big 10 microfarad electrolytic on, and you can see there's a plus sign for the long lead and a shaded sign showing you where the gray stripe will go, because these are polarity sensitive, of course. And then we'll put the variable resistor, which the knob will be facing that way, in RV1, resistor variable 1. And I will do the middle leg, and this is not flat at all. As you can see, I got it all tilted, which is fine, because I will just reheat that solder joint, move it with my thumb, let the solder joint cool, and there we go. Now we're straight up and down. And I'll do the other two. Now I'm going to put the battery snap cap in. Ground is the black lead, black wire. VCC is the red wire. That's positive voltage in. Then the middle is the output. It's the same output that's going to the LED, so you can get that trigger pulse coming out there if you want. Let me trim this lead. It's bugging me. Now we'll put the LED in, and I usually put these flat on the board. I'm not going to this time, and I'll show you why when we get to running this. So again, the long lead goes in the position marked plus. I'm going to kind of set it like that. Again, I'm not going flush to the board. I usually do, but we'll see why in a little bit. And now we'll put the chip in. Even if it's a little more, I don't know, cumbersome because the variable resistor is, I'd like to put the chips in last, just because as I'm still working on soldering stuff, it could theoretically cause a problem, and I don't want to cause problems. So we'll put that home. All the pins are in, they're straight, not bent, and they're all seated. So let's do this first. We'll take our little, I'm going to turn iPad off. I'm going to turn this little light off, and we will plug this in and get her to oscillating. Change the resistor value, and you can see how it changes the speed. Now what I left that little LED up for is I want to take my little Velaman digital oscilloscope that I put together a couple of weeks ago and I put on the channel, and we'll take a look and see what the signals are actually coming, what they're doing. So I'm going to put this, I'm going to hopefully get this so I don't, this doesn't have the best leads in the world. So I'm going to, and this came out of its little rubber insulation or plastic insulation. I want to put it back in. So we'll clip the black alligator clip to that lead, and we'll clip the red alligator clip. I can't see. You see what I'm saying? Yes, you are. Red alligator clip lead here. And now you can see on the little digital oscilloscope, we've got our pulses. They're very broad, very long, but as I change the variable resistor, you can see as I change it, you'll see the frequency change. And now that's going too fast for it to flicker. Now we'll go back, slow it down a little bit more. Again, I built this a couple of weeks ago, and it's on the channel. It's a nice little unit, runs off a couple of, 3 AAA batteries. It's not a world-class oscilloscope, but it's a good educational one. You may want to put it together, even though this connector is really a pain. But again, I don't want to go too on. We're not talking about this oscilloscope. We're talking about the Astable timer. So there we are. Another Astable timer. We've got 2 of them now. The surface mount version, which is very tiny, and the through-hole version, which is not very tiny, but still does roughly the same thing. And it's a good thing to learn from, and you can take this little circuit and apply it to many things you might want to build in the future. And also when you're looking at a circuit, you can understand what this is for. And I hope you enjoyed the video.